Hello, welcome to the class of additional mathematics. With me here, your teacher and honest as usual. I've come with this question on the chalkboard, which is coming from the past paper 1. Okay, so this question carries 4 marks. Okay, so now can you pay attention, Madam Shamangara, and see how best we are going to handle this particular question. Prove the identity 1 over sine A cos A minus 1 over tan A is equivalent to tan A. Okay, so when you see the 3 lines there, it simply means equivalent. Okay, then when we have 2 lines there, equals. So now quickly let us see how we are going to answer this particular question. Remember, when you are dealing with the identities, always should get you back to various identities that you may know. One, Pythagorean identities, those ratios and quotient identity. They are very, very important to master. So now, how are we going to move from here so that we can prove that this expression is equal to tan A? So let us see. So first of all, we are going to write this one, which is tan 1 over sine A cos A minus, but for this one, since this is tan, we are going to change this tan, okay, using the quotient identity. So we are going to say here we have 1 on top. Remember, this is divide by, okay, divide by. This tan, the way it is tan in quotient identity is sine A over cos A. So this is tan. That's what it means. So we are writing this one, then divide by, which is this one, then equals tan, which is this one in this case. So we are saying 1 over sine A cos A minus 1. This time, the rules that are here, you are very much familiar with. Where there is division, when you are trying to simplify the fraction, it always becomes what? Times, and this should reciprocate. What do I mean? Sine, cos should be on top, then down there we should have sine A. Then remember here we have to say over 1. So let us simplify this. So we are going to have this. We are just bringing down this one over sine A cos A minus, when we say 1 times the cos A is cos A. Then 1 times the sine A, sine A. Okay, so we can use this space, okay? Then now from there we can look for the common denominator between this now. So we are going to look for the common denominator, which is common denominator in this case is sine A cos A, because this is sine A cos A. So we are saying sine A cos A is our common denominator. So now we can say sine A cos A into sine A cos A, the answer is 1. Then 1 times the numerator, which is 1, is 1. Okay. Remember here we have minus. Then we are saying sine A into sine A cos A. This sine A and sine A will cancel. We are going to remain with what? Cos A. So cos A times cos A on top there, which is the numerator. We are going to have cos A squared. Okay, so that is our new expression. Then from there, we are still moving on. From there now, we are going to say this, when we go now, we are going to adopt another identity, which is Pythagorean identity. So 1 minus cos A squared is same as sine A squared. So this is sine A squared over the whole of this, following the Pythagorean identity, is equals to sine A squared. So this is the answer there, the one that you have put. Then over sine A cos A. Okay. Then from there, we can use this other part of the body. Now here, when we have sine A, we want to simplify further. When we have sine A squared, this is same as sine A over sine A cos cos A. So now this one will go with this one. Okay, so on top there we have just made with sin A over cos A, which is same as tan A. This is same as tan A. Hence the proof. So we have proved that this angle, this expression to the left hand side is equals to this one. So we started with the left hand side. That is the way to go on identities in trigonometry. Remember, we are still in trigonometry in additional mathematics. I'm sure I posted the coverage topics from November to June, the time when you'll be writing your exam. Thank you so very much.